Hello. So we're going to be learning about the logarithmic function today. As you can see here, I've drawn the logarithmic function along with the exponential function 2 to the power of x. And then I have log base 2 x. I've drawn them out. We're going to discuss the graphs, a little bit of information about the graph, a little bit about logarithmics, and I also have charts that display the x and y values along with the graph. And then we're going to also be talking about switching logarithmics to exponentials. So we're going to be talking about switching logarithmic equation, or the base logarithmic equation, and the base exponential equation, basic exponential equation, and we're going to talk about interchanging them between the two and everything else in between. So let's begin. So if a log is without a base is this letter right here, assume the base is 10. If it doesn't have a number there, just assume it's 10. The logarithmic function is the inverse of the exponential functions. And if you've taken previous mathematics courses before, you should know what the inverse is. It's just interchanging x and y within a function and then solving for x, and then you get a new function, and that new function is the inverse of the original function. As you can see here, I have charts that have the x values and the y values. 2 to the power of x and log base 2 x is the y values, and then x is the x values. And I have the chart there labeled out along with the graphs of 2 to the power of x and log base 2 x. I have them graphed out right there. I have domain, range, vertical asymptote, horizontal asymptote, x-intercept, and y-intercept. So that's some information about the logarithmic graph, if you wanted to know more about it. So we're going to be converting logs to exponentials. And so we have the base, we have the y, which is the answer, and then we have x, which is the exponent. So for logarithmic equations, or the base logarithmic equation, or the basic logarithmic equation, you're looking for the exponent. So x is to what power, or to what exponent. And that's what you're looking for there. So b is the base, y is the answer, and x is the exponent. B is the base, y is the answer, and x is the exponent. So, along with that, let's move on. So we're going to be converting logarithmics and exponentials. So here it's logarithmic. It's logarithmic 2 exponential. And here it is exponential 2 logarithmic. There you go. So, we have a base of 2, an exponent of 3, and their answer, or y, is 8. So that's how you would rewrite it in exponential form. As you can see with question B, we don't have a base, so we're going to assume the base is 10. We have exponent of 3, and to get the answer, we just need 3 zeros. So again, we don't have a base, but we do have an exponent of 1, and our answer is 10. Again, we don't have a base, so we're going to assume the base is 10. We have an exponent of 0, so we're going to use our 0 laws with our exponential rules, and our answer is going to be 1. So for the base, it's just a b, and with an exponent of 0, and again, our answer is 1. We're using the 0 law there. So 2 to what power the power is half, equals the square root of 2. So for that one, we're using, let's go, actually, so for that one, I believe we were using the rational exponent law, because we have a fraction, and again, anything to the power of half is just the square root of the number. Now we're back in it. So that was logarithmic 2 exponentials. Now we're going to switch it up and we're going to go to exponentials to logarithmic. So let's get started here. So we have a log. I wouldn't normally have to write the base of 10, but I'm just going to do it for more clarity. Our answer is 0.01 and our exponent is -2. So our base, our y, and our exponent. So we have our log, our base is 8, our answer is 2, and our exponent is 1/3. So we have a log, our base is 4, our answer is 256, and our exponent is 4. So we have a log, our base is 2, our answer is 0.125, and our exponent is -3. So that's converting logarithmic and exponentials. If you want to look in a textbook or ask your teacher for basic logarithmic equations too, those are this right here. If you want to ask for more practice with those, instead of just converting them, you could practice these, because that's our main focus in logarithmics. Okay, so we have the power law of logs, which is the most commonly used one because we use it in exponential equations. So log base x to the power of n, and that n comes down here and becomes a part of the equation. We use it in exponential applications. We use it in exponential equations. That's the most commonly used one. And then we're going to be doing an example of the product law of logs and the quotient law of logs. We're going to be doing an example of each there. It's log m multiplied by n, and then it works out with addition, and then we have log m over n, and then it works out to subtraction there. Okay, let's begin. So if you want an example of the power law of logs, watch exponential rules and equations video. It's a previous video of mine for the power law of logs. And if you want to look at logarithmic equations, not the basic ones, but the exponential ones, you can see it in the same video. So let's go on to our examples of the product law of logs and the quotient law of logs. So log, our base is 8, and then we have 4 multiplied by 16. A log 8 to the power. Okay, so 8 to what power, to what exponent equals 64? And our answer is 2. Moving on, we're going to be doing log base 3, and it's going to be 405 over 5. Log base 3, and our answer is 81. So 3 to what power equals 81? To what exponent does 3 need to have to equal 81? And our answer is 4. Let's circle our answers. And that's how you use the product law of logs and the quotient law of logs. So that's everything for today, and I want to thank you very much and have a great day.